Okay, we're going to take a look at 1.3, combining transformations, or a further look, I guess. We did look earlier at these 5 steps to keep ourselves organized. So step 1, determine the horizontal stretch factor of 1 over the absolute value of b. Step 2, just determine if there is a horizontal reflection. Okay, and if there is, then that b value that you found is negative. Step 3 is determine the vertical stretch factor. And then step 4, determine if there is a vertical reflection, and if there is, we will have a negative a. And then finally step 5 after that is determine if there are any horizontal or vertical translations. And then we had this little graphic that would help us with mapping. So again, horizontal stretch, and is there a reflection? So we're kind of going this way. Is there a reflection? We go up to vertical stretch. Is there a reflection? Go up to our translations. And we end up with this, which I more often write as A times F of Bx minus H plus K. Okay, so that's a couple tools that we have in our toolboxes so far for 1.3. Okay, so example 4, and let's just first, the original instructions of this example are determine the equation of each transformed function. So y equals x squared is our original function, and then these things happen. So what's the equation of our transformed function? Okay, so we have y is equal to x squared is reflected in the x-axis, for stretched horizontally by a factor of 3 and translated so that the vertex is at 10, negative 4. Okay, so let's just take this one step at a time. The first thing they tell us is that we have a reflection in the x-axis, which means I have a vertical reflection, which means that my a must be negative. My a is less than 0. Okay. The second thing that I'm told is I have been stretched horizontally by a factor of 3. Okay, and what b is actually 1 divided by, or 1 over my horizontal stretch factor. So b is actually 1 over 3. If I knew b and I wanted to find my horizontal stretch factor, I would go 1 over b. So that would be 1 over 1/3, which would actually give me 3. So that would give me this. So those both work the same way, forwards and backwards. And then finally, we're translated so that the vertex is at 10, negative 4. Well, let's think about this original function. Okay, that originally has a vertex at 0, 0. It's usually at the origin. So the original vertex is at 0, 0. So what that means is that I have moved 10 to the right, and I've also moved 4 down. Okay, so this is my third piece of information. So in my third piece of information, I've found out both my h and my k. Remember, h is the opposite of what, h is going to be 10, but then when we put it into our actual function, it's going to be the opposite sign, because remember, it's x minus h. Okay, and then my k, we've moved down 4, so my k is just going to do exactly what we heard that we were going to do. Now, we had a reflection in the x-axis, vertical reflection, but we didn't have a vertical stretch. So what that tells me is that my a value is actually just negative 1. And instead of writing negative 1, I'm just going to write a negative sign. Okay, then I know that my b value was 1/3. Okay, and then I have x, and I moved 10 to the right, so my h is 10, which means in here I actually end up with a negative 10. Since it's x squared, all of this stuff is going to be squared, and then what I have at the end is this vertical translation that takes me 4 down. Okay, so my original is y is equal to x squared. After these transformations have taken place, I end up with this function here. Okay, another example from your notes. The graph of the function y is equal to g of x represents a transformation of the graph of y is equal to f of x. So here my blue graph is my original and my red graph is after the transformations have taken place. We are asked to determine the equation of g of x in the form, our standard form there. Explain your work as you proceed through to your solution. Okay, so if we go back to our steps, one of the first things that we were supposed to, or sorry, the first thing we were supposed to find out is, do we have a horizontal stretch? Okay, and what I'm going to focus on in this one is, well, what's the distance between these 2 points in my original graph? And the distance there, well, I go from -4 to 4, so this distance is actually 8. I have 8 units between those two, and the distance between my transformed graph, those same 2 points, is only 2. Okay, so if I think about a stretch, well, I clearly got 4 times smaller. So I'm going to write that I have a horizontal stretch factor of, so if I got 4 times smaller, that's like saying it's a quarter, right? 2 is a quarter of 8. And so what that means then is B, like we talked about before, is always 1 over the horizontal stretch factor. Okay, and so what that tells me then is that B is equal to 4. So in my transformed equation, I have a B is equal to 4. Okay, this shape is symmetrical. It's exactly the same on both sides. So we can't actually tell because it's moved over, we can't actually tell if there was a horizontal reflection or not. You could say there was or there wasn't, and you would actually be right either case. Okay, we also, or sorry, our next step is to take a look at the vertical stretch factor. And this one's a little bit nicer because remember, it kind of does exactly what it says it would. So in our original graph, and let's look at how tall this graph is from the points we've been given. Okay, it's got a height of 4. How tall is this other graph? Well, it goes from 2 all the way up to 10. So it's got kind of like 8 units from the bottom to the top. And so if we go from 4 to 8, well, what happened? It got 2 times larger. And so that means that our A is equal to 2. Now in this one, you can pretty clearly see that we don't have a vertical reflection. The V didn't go from up to down. They both are up. And so we have a positive A. So next piece of information we're going to look at is how far did these points move? So for example, how far did this, we'll call it the vertex, move left or right to get from here to here? Well, it moved 1, 2, 3, 4, 5, 6, 7 spots left. Okay, so that would mean that my H is equal to -7 for 7 spots left. And then if we think about my K, well, we moved from here, we actually moved up 2 spots. So my K is a positive 2. Okay, and then what I can do with all of this information is write this function out in our general form there. My A, we said, is positive 2. Okay, and then we're going to go 2 times f of, my B is 4, and then I'm going to have x, and instead of -7, since it's minus h, I'm going to have x plus 7, and then at the end what I'm going to have is this plus 2 for my k. All right, now we use this little f when we're talking about a function that we don't actually know its equation, like in these ones. So just to recap the steps that you should do: figure out the horizontal stretch factor and reflection, figure out the vertical stretch factor and the reflection, and then figure out if you have any horizontal or vertical translations.